because the jib strip, that thing, clearly needs to be in place at the time that we slide this down the column. See how far we get the column on. Basically, keep the Gibb strip out and don't have it in at the time. Where am I? I'm looking upside down here. Put my finger on it. Oh, right, okay. There we are. There's the jib strip in there, which means taking all these, not taking them out, but slackening all the jib screws off. There. Put the main head all the way down to the bottom onto a piece of wood. It'll be below the bottom edge of the rack and pinion, the rack. Then you can drop the jib strip in down there, and then tighten up the screws until it just begins to grip, and then you can lift it up until the rack begins to bind, and it's a two-person job really to get that. So it's dropping the head on without the jib strip in, putting the strip in, and now what we're going to do is take that screw out of here so we can put the counterbalance arm in place, and it should then become stable, or more stable. So we've got it so the rack and pinion can hold it. Down a touch, I think. Is it? Down a touch more. Yeah. Oh, I got it. Let me just turn this off. A very minor issue is that it doesn't come with the screw and washer to allow you to fix the chuck onto the MT3 taper arbor. The chuck's quite a good interference fit on the end there anyway, but it would be nice just to have the washer and screw in. Now, powered it up. It's set to the low speed on the gearbox on the side there. If I set that to forwards, turn the speed down and press it on, there you hear it whirring. As it speeds up, I hope you can hear from the sound, it sounds really quite noisy. I find that very noisy. Turn it down, let's stop it. The other way, start. Also noisy. Gears sound very noisy there, so I'm definitely going to have a look at those and see why they're noisy. This cosmetic cover, whoa, comes off, as does the plastic cover which hides the top end of the the drawbar that would go through to hold the MT3 thing in the arbor. So that goes on there. Anyway, I'm going to have a look at the gears and also at the rack and pinion. I'll let you know what I find about that. The other ways seem smooth enough, just a lot of backlash, but I'd read about the fact that there's lots of backlash with them anyway, because of the fact it's a very simple threaded rod and nut arrangement under there. There's no ball drive, so you've got to expect there's going to be backlash. So, but well, it's turning reasonably smoothly. Let's not say any more. Let me investigate that noisy running sound and the rack and pinion rise and fall issue. I've just taken the cosmetic cover off the bar that represents that drives the slow feed, and that's locked into there with the rise and fall on the rack and pinion at the back. The thing that I note is that it's really, well, it's just slipped down a notch. Hard to engage and disengage that dog tooth arrangement in there. I can't disengage it at all. Very hard to engage and disengage that locking ring dog tooth mechanism. There we are. That's it. Disengaged, as you can see. in the slightly out of focus image there, and the handles slide up along that and should engage into that, but it's quite tight. Just a quick check to see if the spindle runs approximately true. I'm just taking it off the chuck, the supplied chuck. So I'll turn the speed down. Let's see what happens. Right, on the chuck you can see there a wobble of about, well, it's a few thou, isn't it, on there. Okay, let's stop that one. It could be that the chuck itself isn't quite untrue, so let's try it on the arbor. The zero's in a different position, but I've got it resting on the arbor. Taking the chuck off. That's much better in terms of the variation there. Don't know how to show that, but it's... oh, I'll tell you what. Stop recording. There we are. That's clearer, isn't it? You can see that better now. If I turn that... oh no, if I touch it, it moves the thing, doesn't it? Just try with different speed. See it. So I can work out how much that is at some stage afterwards, but it's about 1 division of the micrometer. Yep, the black scale. I don't suppose there'll be any difference. Set it into reverse, will there? Set into reverse. It's interesting. It seems to be moving. I just turned it from forward to reverse. Still about 1 division. Seems to have moved over. Maybe it's just because I moved the machine. You keep watching while I change this. Stop. Move the machine there. I think I might have moved the machine a bit. It does seem to be slightly different forward and reverse. Yep. Seems to be about half a division difference between the position forward to reverse. So if I stop it, it's on 1 of the divisions, and then just start it momentarily. Yeah, it's gone the other way. Okay. One of the things it's suggested you do in the manual is raise the motor to the highest height when not in use. Well, that's going down. This is going up, and now the problem is it's completely missing it. It's completely not turning at all. So I can turn this. I don't want to turn it anymore because presumably if it's just missing the teeth, it's grinding away at the teeth on the rack. Now there's the gap at this level between the rack and the casting. If I take it down, it still sounds very bumpy. Does the rack? No, that gap doesn't seem to get any less, and I think I've gone off the end of the rack there, the bottom. That is so notchy coming up. And if I try and rattle the head about, the head is been adjusted very nicely using that Gibb strip, so it's a reasonable fit on the dovetail. But I really don't like that notchiness about the rise on that rack. I really don't like that. And then it starts to slip there and there's nothing happening. That's about whatever the measurement is on there. It's barely 1/3 of the way up the column, So we've got the gash there and the rack not working there. Don't know what this does, but this is just the play between the motion of the spindle and the gears. So that's the amount of play there is in there. So a couple of things really that leave me wondering if this is a machine worth keeping. Just a few points. I've taken the cover off there just to see what's going on with things. I've now spent a bit of time adjusting the Gibb strip on the column. The play between the pinion and the rack is about that much. If the Gibb strips aren't properly adjusted, then it's nice and tight now, and there's no, well, it obviously doesn't shake about because it's quite tight. Anyway, there we are, we've got the play, and that's quite stiff. It holds itself in any position. Obviously you've got this locking screw onto the Gibb strip as well. Interesting though, you know, you look at it, it should have been obvious to me. On the dovetail, this part here is machined, glass-like finish, beautifully machined. That part is rough, it's really quite coarse. And yet then when you fit the thing and adjust it up, you realise that, and you probably can't see it from here because I've not got my torch on, if I put the torch on, well, at some level, that nothing bears on that surface. You know, if it was a lathe bed, this, then you would see various parts bearing on there with some support on the dovetail part. But in this, the bearing surface is actually the flat bit at the back. So if I illuminate it, once the Gibb strip is tightened up, the bearing is on the back. That's, if I can get my finger in there, hold this in my mouth. That's the bearing surface. That's no good. Good grief, people. What am I doing? Yep. So, that is the bearing surface, not that. So this beautifully mirror finish, nicely ground and finished surface isn't touched at all. That surface, which you can hear the scratch, that's the bearing surface that's being used. And the other bearing surface is the inside of the dovetail, which again, you can see better on this side, is not the smoothest. So it's not bearing on a particularly smooth surface. You can see them there. See what that has. But there it is, it's nice and tight and it runs up and down. What I don't know is how true it is when it runs up and down. So that's all to be tested. The next thing I'm looking at is the bearing surface. Here we have the bed, the table for the longitudinal run. And again, the bearing surface is this one and the inside of the dovetail. That super smooth edge there, you can't just see it. Anyway, these surfaces are quite coarse, certainly in comparison to the smooth finish on that one, the relatively smooth finish on that one, and the relatively smooth finish on the top of the dovetail surface here. But I'm not quite sure exactly what impact that will have. Now, this is a method recommended in the milling book. There's a guy who's written a couple of milling books. They're the only ones in the workshop series, the popular ones. Just can't remember his name at the moment. Anyway, so I've weighted a piece of glass onto the bed there. I'll get onto the table. At one point, alright, at that point there it's 0. Yep. It doesn't go below 0, so at one point there it's 0. It rises up as it's going round there. At this point here it reaches maximum, and then it comes down again back to 0 when it gets to there. That's fine, because what that means is that the column, let's pull it, yeah, the column is leaning slightly that way, because it's higher here, right? So it's higher here by whatever, 30, I don't know, it's 30 thou, whatever it is. Anyway, that's fine. We know these columns need a lot of adjustment to get them into the true vertical position, even though it's locked in position, so that helps. But the good news is the height here and the height there, front and back of this, are about the same, which means the column is fairly well perpendicular or vertical when in relation to the bed when viewed that way, which I'm quite surprised about really, because all it is it's just clamped through with a single bolt onto a circular bearing surface at the back down there, and it seems to be that that's fairly well at right angles to this. I've tightened up all the jibs. I don't know what sort of extra strain that's going to put on the nuts, but it just makes everything a lot tighter, so there's absolutely no play in the system, because you do need to move these things while cutting. Well, and now see what people mean when they talk about setting the column to vertical. Lots of gentle taps on the column. Moves quite readily, but it's this process of splitting the difference in terms of the measurements. And now, how do I tighten the nut on the back without disturbing its truth, its vertical position? Because I've been here before with other systems, and as soon as you start turning something, you start moving something, they don't stay in the same position. Anyway, nothing ventured, let's have a go.